Welcome back to my channel, Calculus Help Now, and today we'll be working on vectors and the geometry of space part 2. So let's draw something that's pretty familiar to us, our y-axis and our x-axis, an xy graph. And this would obviously be our x-axis, or y-axis. And in two-dimensional analytic geometry, as this is two-dimensional, the graph of an equation involving x and y is a curve on r squared. So let's just say we have an equation y equals 5. Right, so let's go 5 units up and draw a line using a yellowish color. So here we will have a line at 5, y equals 5. This would represent the equation y equals 5 and real number squared. And what we're trying to transition over to will be the z-axis, the positive z-axis, the positive x-axis, and the positive y-axis that would make up a part of the real numbers cubed, and this will be in 3 dimensions. So to our left, we see a line at y equals 5, and to represent that in 3D, let's just draw a few lines. 5, 1, 2, 3, 4, 5, and then finally 1, 2, 3, 4, 5. Right? 5. And let's draw this plane, which is the conversion from the line in 2D into 3D, which will be a plane. So we will draw something like this. That. And I'm only drawing a piece of the plane because it goes on forever. So I'm just going to draw a piece of the plane. It's an area of a plane. So this here would represent this line in 3D. So it's still the same equation. It's y equals 5. But in 3D, it would represent this shaded area. And remember that this shaded area, the plane is very, very thin. It's not like a cube. It's not anything like that. It's as thin as what can I use as an example? Let's just say it's not necessarily as thin as the width of a piece of paper, but think of it like that. It's very, very thin, and it represents all coordinates with a y component of 5. So in general, if we let k be a constant, then we can say that when x equals k, this would represent a plane that's parallel to the yz plane, right? And then we could also say that when y equals k, it would also represent a plane that's parallel to the, what do you think, the xz plane. And finally, we could finish this by saying that when z equals k, it would, the same thing, represent a plane parallel to the xy plane. And with this, it would also help to answer questions regarding which point would be found closest to a particular plane, whether it's the yz plane, the xz plane, or the xy plane. If you find that whatever plane that you're trying to find it closest to, if you find that the x coordinate of the order triple has a number closest to 0, then you could say that it's probably the point that's found as close as possible to the yz plane. Or if you find that the value of the order triple for the y component is closest to 0, then you could also say that it is the point that is closest to the xz plane, and so on. For this question, it asks us which points x, y, z satisfy the equations x squared plus y squared equals 1 and z equals 4. So right off the bat, we can already say that this equation right here would represent a circle, x squared plus y squared equals 1, and z equals 4, as we just learned, would represent a horizontal plane at z equals 4, so 4 units in the vertical positive direction, the z-axis. So this would be a horizontal plane, right? And so first, we'd have to draw our tick marks. So I will draw 4 tick marks on each end of these axes. And we also have to consider the restrictions on both of these equations. So on x squared plus y squared equals 1, we know that the radius is 1, and it has a center located on the horizontal plane z equals 4. And we could first draw the plane z equals 4 in a orange color. One moment. It can be drawn somewhat like this. Remember, this is a height of 4. Just have to imagine that. So this is just a small area covered by this horizontal plane. So I'm gonna sort of shade it in orange. And to draw the circle, we're gonna represent that in a sort of yellowish color once again. And I will use this feature. So remember that it has a radius of 1, so it'll go 1 unit in the positive x direction, 1 unit in the negative x direction, 1 unit in the positive and negative y direction at z equals 4. And to make life possibly easier, we can draw another parallel dotted line hitting at z equals 4, so it'll strike through. So this will be our imaginary x-axis and another parallel line representing our imaginary y-axis at z equals 4, just so it might be easier to draw this circle. So I'll draw the tick marks again. It's about right here, and then right here. And then finally, we'll actually draw the circle in a greenish color just because we already used yellow. So to begin drawing it, we have to consider all four sides of this. So it would look something like this. And you just have to imagine that it would be hitting each end of the x and y axis at one unit. So this is one unit in the positive directions of the x and y axis, and you can't really see behind it. But if you were asked, what would this equation, x squared plus y squared equals 1, represent as a surface in 3D? Well, again, you would draw the tick marks. So I'll just quickly draw the tick marks. Yeah, that seems right. And we would sort of do the same process as shown on the left. So without drawing the dotted x and y lines to help us draw this circle, we're just going to do it with the pinkish color. Just going to do it without them. So it would be about like this. One moment. It looks something like this, right? In a pinkish color. And you have to remember, a surface, it would continue on forever. And since this is it really just is a cylinder, you would see many of these circles, and obviously I can't draw all of them. I'll just try to represent them in a neat, fair way. Just draw some of them, like this. Draw a few more. And one more. So basically, to draw this surface in 3D, it would actually look like this. So I'm going to draw a shaded region in a lighter pinkish color. So it would kind of look like this. And I'm making sure that it has a radius of 1, right? And it would continue on forever as a cylinder, which is actually pretty interesting to draw. I'm just going to fill in this region with a light pink color. And remember, it would continue going the negative direction of the z-axis, the positive direction of the z-axis as well. And as you've learned in prior chapters, you know that representing x squared plus y squared equals 1 would be a cylinder, since the missing component, as you see, would be z, and that's actually the path that the cylinder would run along. So they're asking us to describe and sketch the surface in basically 3D, represented by the equation x plus y equals 2. So before drawing it in 3D, what might be easier or helpful would to draw this in 2D. So first we draw our y-axis, then our x-axis. So we would move the x to the right side of the equation. So it would become y equals negative x plus 2, right? So we go 2 units, the positive y direction, and it would have a negative slope of 1. So a negative 1. So we can just start by representing this line in a reddish color at the y-intercept of 2, right? Just be about right there. And if we do the rise over run of negative, it's a slope of negative 1. So you go down 1, then you move to the right 1, go down 1. I draw little dots, little points. Move 1 unit in the positive x direction, 1 unit in the negative x direction. Should be about right here. Then again, positive direction, negative direction, whoops, and then another last point be about right here. Then if we were to draw more tick marks, 1, 2, just to speed through this, rise over run over here, rise over run. So now we have our beautiful line, and let's just draw our line through it. So it would look something like this. So this line would be representative of the equation y equals negative x plus 2. So if you think about it in 3D, you have to imagine that it's a bird's eye view. So you're looking directly down at this plane. So if I were to draw it in 3D, let's see, it'll give you a better understanding of what I'm talking about. Draw our x-axis. I mean our z-axis, my apologies. Then our x-axis approaching us, our y-axis. Y. And then we have more tick marks, so let's say 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and finally 1, 2, and 3. So to represent this equation, this line, which will now become a plane, think of it as a bird's eye view. So I'm going to just do it in red once more. This time, you can see that this right here would be the positive end of the y-axis. And if we extend it a little bit more, this is just a sort of area. It's a region of the xy plane. That's what we're dealing with right here, right? So if we were to draw this line again, it would look something like this, but it would actually be a plane. One moment. Draw the bottom portion of it. Something like this. Again. Oops. Let me redo that. One moment. And then again. So this would actually be the plane x plus y equals 2. And I'm going to shade in the region that makes up this plane. Remember, it's really, really thin. The thin surface. This is a plane. Okay, so if you imagine bird's eye view, so I'm going to draw a small, tiny bird. It's going to be blue. Up here, I'm not sure if my bird drawings will be that good. Looks more like a plane. And imagine eyes, like right here, looking directly down. One moment. Looking directly down. It's looking down, and that is actually the view, the perspective that the bird would be having. So you wouldn't actually see the plane. It looks somewhat large here, but like I said, it's really, really thin. Obviously, this isn't super, super thin, but it would look something like this. You get the analogy. It would be very, very thin, and we would be on top of the plane, or on top of the XY plane, as we see down here. This would represent the XY plane. And so sometimes drawing it first on a XY plane and then transitioning it over into the 3D coordinate system might help in drawing these, whether it be points or drawing planes. It might be easier at first to draw it on a XY plane. So that'll be it. I hope this was another useful video. If you, again, have any comments, questions, or concerns, please don't hesitate and just write it in the comment section. I hope so far that you've enjoyed my videos and that they've served some sort of purpose in your life and in your course. So I'll see you in the next video. Thank you.